This is question 6 in 6.2, and this is another odds question. Well, the entire chapter is about odds. And this question says, if the odds in favor of Boris beating Elena in a chess game are 5-4, what is the probability that Elena will win an upset victory in a best-of-5 chess tournament? Okay, so like with every other question in this chapter, we are going to remind ourselves the definition of odds. So you can pause the video and check that out if you want, but we're going to remind ourselves of the definition before we continue. Because this question mentions the probability, it wants us to find the probability, and it gives us odds. We know that we're going to go from odds to probability. How do we do this? Well, I did discuss this in class. If you didn't catch it, this is how you do it. You just think about what odds means. So odds in this case, we're talking about number of outcomes where an event occurs here, to the number of outcomes where an event doesn't occur. So here that's going to be 5-4, so that's what it gives us here. This basically means that if Boris plays 9 games, by the way, that 9 is 5 plus 4, that's where that 9 comes from, 5 plus 4. If Boris plays 9 games, out of those 9 games, 5 of them result in his victory, and out of those 9 games, 4 of them result in Elena's victory. So we kind of have already turned odds into a probability. We can define our event. Let's say it's Boris. So B is Boris wins. So the probability of B is going to be 5/9. Because again, we know that we have 5 outcomes where Boris wins a chess game versus Elena, and then we have 4 outcomes where Boris loses a chess game versus Elena. So if we add 5 to 4, that's the total number of games that they play, and that's 9. Out of those total number of games, he's going to win 5 of them, which means he's going to lose 4 of them. So we get our probability for Boris, probability of B, probability of Boris winning. We also get our probability of Boris not winning. That's B complement or B prime. This is 4/9. But the question asked us for Elena winning. So we kind of need to flip our perspective, and I'm going to introduce a new event called E. E is going to be the chances, or E is going to be the event where Elena wins. So for E, probability of E is going to be 4/9. That's the same thing as Boris losing. And then the probability of not E, in other words, chances that Elena doesn't win, chances that Boris wins, that's going to be 5/9. Okay, so that's pretty good. We have our probabilities for Elena and Boris. And we need to look at the probability that Elena will win an upset victory in a best-of-5 chess tournament. Best-of-5 means that Elena needs to just win 3 games. The moment that she wins her 3rd game, the tournament is over and she has won the entire thing. So we need to consider what's possible, what are the possibilities in this case. So you can do this in a few ways. I guess my preferred way is to draw a tree diagram. But if you don't want to do that, you can just list it out. So actually, why don't we list it out first, and then I'll draw the tree diagram, because the tree diagram is much larger and it might take a bit of room. Or sorry, it might take a bit more space. So we can list out all the possibilities. So for example, Boris could win the first 2 games, and then Elena could win the last 3 games, the 3rd, 4th, and 5th game. That's one possibility. Second possibility is Boris wins the first game, and then Elena wins the next 3 games. Third possibility is Elena wins the first game, Boris wins the second, Elena wins the 3rd, 4th, and 5th game. Fourth possibility, we don't need to play the 5th game. Just it's just third and it's just third and fourth and fourth. The moment that she's won like the 4th game, then she wins the entire thing. What else could we do? We could do Elena wins the first 2 games, then Boris wins the 3rd one, and then Elena wins the 4th. We could do Elena wins the all 3 games in a row. That's fine. We could do Elena wins the first 2 games. Oh, sorry. Elena wins the first game. Boris takes the next 2 games, and then she wins the last 2 games. We could do Elena wins the first 2, and then Boris wins the next 2, and then Elena wins the final game. And I believe these are all the possibilities. So we're going to check that they're all the possibilities. You could list out all of them like this, or you could draw a tree diagram. So this is a bit more, I guess, foolproof if you draw the tree diagram. You get to see what is going on. So the difficulty of this is that we don't actually need to draw all of them. So I'll write Elena and Boris for this. Here you could do like E comp. Oops, you could do E prime or E complement. I'm going to do B and E because this way these 2 are distinct, and that's a little bit better if they are distinct like this. Why is my laser pointer? So there we go. All right. So that's the first possibility, and then we can have E wins, B wins, E wins, B wins. So this path here, this topmost path, is already our 5th scenario, so we're good there. If Elena wins, and then if Elena wins the first 2, then we have Boris wins the next one. Here we could have Elena wins, and then Boris wins, and then finally we could have Elena wins. Yeah, so here, for this path right over here, we're going to stop here because we already have Elena winning 3 times, so there's no need to go any further. What else do we need? If Boris wins down here, just get rid of that. If Boris wins down here, then we could have a case where Elena wins, Boris wins. Actually, I should really just flip these. Let me just take care of that. Let me just that there, this here, this here, that there. All right. Then we could have Boris wins. Here we could have Elena wins and Elena wins. So this path, this path here, you have to draw like this because once Elena wins and then Boris wins twice, the only way for Elena to win at this point after the 3rd match is if Elena wins twice more in a row. So you have to draw this path like this. For this path, Elena could win here. So after Elena wins this, Boris could win, or Elena could win. And if Boris wins his 4th game, then Elena will win her 5th game. All right, so that's that part taken care of. Down here we can have Boris, Elena. Here we can have Boris, Elena. Here we're going to have Elena and Elena, because again, if Boris wins his first 2 games, if Boris wins 2 games, then the rest of the games need to go to Elena. So it has to be drawn like this. This to be Elena, this to be Boris, this to be Elena. And then down here, this to be Elena, Elena, Elena. And this could be, oh, there's only one possibility. Never mind. For this, there's only one possibility. At the bottommost branch, it has to be like this. Okay, so just looking at these branches, I see 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. Which means that I missed out on 2 of them. And this is why you draw the tree diagram, so you guarantee yourself that you have all of your bases covered. You have all of the possibilities. I missed this one here, and I also missed this one here. All right, so we have all of the different scenarios. And we know that like we have the probability for this, and we have the probability for this. The only thing that's missing in the tree diagram is to actually put the like probabilities on the branches. So for example, 4 out of 9, 5 out of 9, and then you just keep going from here, 4, 9, 5, 9, etc., etc. Okay. So we could do this. I'm going to show like a sample calculation for, let's see, one of them. But all you do is, for example, if you see, let's take this one. The way that you calculate this is you take advantage of the fact that the events are independent, which is to say, if Elena wins the first match, this has no effect that on Boris winning like the next match and the next match after that, and then Elena winning the last 2 matches. So for example, for I think this is the 6th scenario, we would do something. Hang on, we would do something like probability of Elena winning times the probability of Boris winning times the probability of Boris winning times the probability of Elena winning, and then times the probability of Elena winning. And then here, you already know what your like PE and PB are. They are these fractions up here. Oops, sorry. They are, oh wow, that's not what I wanted to do. They are these fractions up here. So all we're going to do is plug in these numbers. Just move that there. So all we're going to do is plug in these numbers. So we have 4 over 9 times 5 over 9. But since we have 2 of these, we can do like 5 over 9 squared times 4 over 9 squared. And you multiply these numbers up. I'm not really going to like do it. I'm just going to say this is 9 to the power of 5, and then this is going to be 4 to the power of 3 times 5 to the power of 2. You can use a calculator and calculate this to get an actual fraction. I'm not going to do that in the video, but you can do it yourself. And you can also use a calculator to calculate all of these other possibilities and add them all up. So for example, we did the, like, we found the probability for number 6. We found the probability for number 6. We need to find something similar for 5, or we need to do something similar for 5, and then something similar for 4 and 3, for all these scenarios. And then we just add up the probabilities. And if you do that, you're going to get the answer in the book, hopefully, which is 7,808 over 19,683. I am not going to do this in the video. You can do it yourself and like check. But really, first of all, this question you probably will not get on a test because just doing these calculations is very annoying. Unless you knew what these numbers were, it would be like not realistic to expect you to sit there and punch these values into your calculator and find all of these like all of the probabilities of these branches and then like add them all up. That's not realistic to do like on a test or anything. Maybe for an assignment that might be okay, but like not a test. There's not enough time. But this is how like you would go about doing the question, and this is how you would get the answer. So there you go.